Good evening, we enthusiasts. We have started the discussion of momentum, conservation of momentum last week. And today I want to discuss the different types of collision that can be encountered. Alright, it's a very special topic, and plus today we are going to do some 2D level problems. I'm going to give you some special cases, some special formulas which will be easy tricks for solving the questions in JEE Mains, Advanced, NEET, KVPY, you name it. All these examinations you can use those tricks which I'm going to give you by the end of today's session. Shortcut tricks. Alright, so let's talk about momentum and collisions are always fascinating to definitely watch it, but not to encounter yourself. Alright, look at these cars colliding, and I'm pretty sure most of you would have seen some car crashing videos. It's terrible to watch, and it's also funny at the same time how idiotic drivers can be. Alright, so let's talk about collisions with me, Shreyas, your master teacher for physics, going live at Vedantu. So I hope you guys had an amazing day, and like I've been telling you, Monday, Tuesday and Wednesday will be 11th standard portion generally in physics, and Thursday, Friday and Saturday will be 12th standard portion. And this channel, we Enthuse, where me, Wasim sir and Shimon sir teach. This is a special channel. It's an English channel for all the JEE aspirants out there, because a lot of students want to learn in English, so that's why we created this channel in the first place. So welcome aboard, and thank you very much for making this family grow bigger and bigger, and thank you for all your amazing support, your likes, your comments, your suggestions, your participation, your engagement. Everything has been so cool, and that's what we want, and that's what we'll continue to do. So like I said, the first half of the week will generally be 11th, and the later half will be 12th. So this is a quick introduction about me, and most of you would already know, but in case you do not, you can definitely read it up, and you can also get in touch with me on my social media handle, which is Shreyas_Vedantu on Instagram. So welcome aboard Barney, Manoj, Tivisa, Kirito, Harsha, Fida, Hoin, VSG, Satish, Sneha. Thank you very much for all those hearts, fires, V's, stars, those dances. It's so cool to see all of you. Hello K.A. Harishran, hello Rameshwar, hello Satyam, hello Ankit, hello 70mm, hello Shara, hello Aarti, hello Science Priya, Richu, Shreya, Satish. Ren, welcome aboard. I'm so sorry if I missed out somebody's name, but I'll generally take somebody's name while the lecture also goes on, if you keep answering the questions correctly. So make sure you keep answering all the questions that I ask you in the chat box whenever the questions come up on the screen. So let's get going, and do not forget to subscribe. All the new members of the V family, do not forget to hit the subscribe button. It's a big red box on this side of your screen. Do not forget to hit that red button, because if you do not hit that subscribe and the like button, I won't get that energy and I won't get that motivation. Understand, my motivation comes from your love, your support, and everybody's love and support is what is going to make this channel grow faster. All right, so let's begin. So now, in my previous session, what have I taught? I have told you about conservation of momentum, and we saw that whenever two or more bodies collide and there is no external force acting on it, then the momentum before and momentum after is the same in magnitude as well as direction. I hope you remember that. We have seen so many examples. In case you are a new time or a fresh student to this channel, and I would advise you to please watch one of my previous sessions on momentum and conservation as well, because that will give you a holistic view of this chapter. All right, it's there in the playlist. You can check it out later on. Now, we have also seen how the law looks like. So say for example, this is the condition before and this is the condition afterwards. V1, V2 are before velocities, and V1 prime, V2 prime are the velocities after the collision. Then the momentum before, I should put a bar over here, strictly speaking. So I'll put a bar. M1 V1 bar plus M2 V2 bar is M1 V1 bar prime plus M2 V2 bar prime. All right, so that's how it is. This is the momentum before and this is the momentum after, and they both are same, assuming if net external force is 0. Remember, internal forces do not matter. So the force of collision is has no relevance in this. Remember that. And one more thing that you should keep in mind, these are all vectors, so keep in account the signs, which side are they moving, right, left, etc, etc. So keep that in mind. And one more trick I told you last time, that always for solving energy problems or momentum problems, always show the situation before and after. If you draw it on the same diagram, there is a very good chance that you will be making a mistake. All right. Now, we know, in fact, in the GIFs or those animations that I showed you or the videos I showed you, you would have seen some energy is lost during the collision. So if some energy is lost, is momentum conserved? Yes, we have seen that question in my previous session. Even if energy is lost, momentum can be conserved. But how do we accommodate this factor in the collisions? Because imagine, I tell you, there are two bodies and they collide, and I tell you to find the velocities after the collision. Here is the problem which one will encounter. See, in this equation, if I tell you what are the velocities before the collision, but the velocities after the collision are unknown, the problem that you will face is that you just have one equation. And for one equation, you can just find one unknown, but here you have two unknowns. I hope you can see that. So that means you need one more piece of information so that you can find both the variables. So that is what today's lecture is all about. So the energy matters, and only when you know the energy factor in, or you somehow take it into account, only then you can find the final velocities. And that depends on the nature of collision. So how to solve these problems? That's what we are going to get to now. And before that, let me tell you quickly about our pro subscription courses, where if you want more of my teaching, you want to study more under me, you want personal guidance, you want maybe some micro courses which I conduct, like the H.C. Verma discussion course, the booklet discussion course. Then the second course is numerical course which I conduct, and also I conduct, yes guys, I also conduct the derivations course, all derivations. And I also teach in the regular batches of 11, 12 standard. And also let me tell you, there are lots of tests, assignments and modules and thorough analysis, so you can improve continuously. You can understand what are your weak points. And apart from me, you also get doubt teachers, class teachers, personal teachers in the app itself. All these are benefits of the pro subscription course. Understand, it's a subscription just like Netflix or Amazon Prime. And you also have in the long-term batches the option to learn in English or Hindi. And also the dropper or the 12th standard students, there is a crash course which is specially designed for you. All of this at a very affordable price. I know you are interested in the price as well. All the new timers out here. All right. So 6 months for the 12th standard students cost 24,000. But I'll give you a coupon code. After that, the price will come down by 20%, and it will be available at just less than 20,000 rupees. It's 19,200 rupees. So for 6 months, yes, till your JEE advance is over, you will see that you can avail the benefits of the pro subscription. And if you are a dropper student also, you will get 20% discount. Just head on to the link which is there in the description box below. Yes, go to the description box and see the link. After the session is over, you can open it on a separate tab if you want now. And what you need to do is enter this coupon code SHHPRO. Only then you will get the 20% off, my dear friends. So do not forget to enter the coupon code, naito you will not get that discount. All right. So I hope I'll see many of you in the pro subscription courses where I'm going to teach, and I'm pretty sure you want to get more involved into the Vedantu family. Yes, so let's get going. I hope the Josh is high. Yes, Devendra, we're going to talk about whether kinetic energy is conserved, not conserved. Yes, Ankit, I'll be coming to 3-month strategy. Don't worry. Yes, Neha, for sure, for sure. I have informed the backend team for getting the PDFs and all that. And please join the Telegram group where the PDFs will be shared very soon. So it's very important you join the Telegram groups where you'll get all the PDFs, solutions, etc. Guys, have you been also checking the solutions which I have been sending you of the previous sessions? How many of you have checked it on Telegram group? How many of you? How many of you seen all the solutions that I have been providing? In case you have not, please go to the Telegram group. I have been giving all the solutions of all the homework questions that I give you. Yes, very good. Excelente guys. बहुत ही बढ़िया. Very good Ryan, Tanmay, Saurabh, Manoj, Kirito, Aarti, Shara, Ashutosh, Shankit. Very good Science Priya. Very good Sarvanan. So now let me come to the three types of collision. One is elastic. Whenever you hear the word elastic, what comes to your mind? Some elastic thing, right? Like a rubber band. Rubber band is the first thing that comes to your mind when elastic word is used. When you stretch it, leave it, what happens? It comes back to its original shape and size. That is an elastic nature. Alright, so you deform it and you leave it, it will come back to its original shape as well as size. But the word inelastic means if you deform it, leave it, it does not gain back its original shape and size. So sometimes if you leave a rubber band for a long time, it loses its elasticity. Sometimes your pants or your knickers also lose their elasticity. You stretch it, leave it, it has deformed itself. It's no longer fitting you. Have you experienced that? I'm pretty sure. Quite embarrassing at some times. Alright, so that is inelastic behavior. And perfectly inelastic, well, I'll give you a very good example, guys. Perfectly inelastic means you deform it, leave it, it does not even come back. It just stays there. Permanent deformation. Example, the cheese on your pizza. You stretch it, leave it. What happens? It stays there. It does not come back, right? Imagine, that would be very weird. If you stretch the pizza and leave it, it comes back. That would be very weird. Alright. Yes, clay is inelastic, Aishwarya. Correct. Papi Reddy, long time no see, yeah? What's this? Come on, be regular, guys. You have to be regular on this channel. Only then you will maintain the flow. You will maintain that momentum. Remember that. Now, if you drop that crazy ball, you would have seen that crazy rubber ball that you get in the market, and you drop it, it almost comes back in the same height, like the red ball over here. Those kind of collisions are called as elastic collisions. So what happens in elastic collision? During the collision, there is deformation. But just after the collision, the deformation is relieved and you will see the original shape and size returns. There is no loss of energy, and that's why the ball bounces back till the same height. That is called as elastic collision. Alright, so no energy losses happen in perfectly elastic collision. Now, inelastic collision. These collisions are the most common collisions around you. Like two cars colliding, you colliding with your friend, or you throwing something on somebody else. All these are examples of inelastic collision. So when you drop this ball or stone, you will see some energy is lost in heat, in sound, or something else, and because of that, it will eventually loses energy and it's going to stop. And guess what, guys, what I have in store for you? Today's session, we are going to find the height which the ball reaches after the nth collision. Yes, the height which the ball reaches after n number of collisions. What an amazing problem it's going to be. Wait for it. And then the last and the worst type of collision, perfectly inelastic. That's the worst kind. Matlab, you drop the ball, that's it. It hits and gets stuck to it because all its energy is lost. So maximum loss of energy happens over here, where you will see that the ball will no longer have any kinetic energy left because everything has been lost in permanent deformation. Like taking a chewing gum and throwing on your friend. Please don't do that. I'm just giving an example. So throw it and that's it. It gets stuck to him. That's a perfectly inelastic collision. If the chewing gum bounces back a little bit, then it is inelastic collision. Understand that. Is that clear, guys? Is that clear, everyone? Let me know in the chat box. Yes. Very good, Ryan. Uncharted, Krito. All right, a lot of laughter is coming out there. बहुत ही बढ़िया, guys. Amazing, Nijerson. Very good. So now let me talk about coefficient of restitution which Newton gave. Now what Newton did, he was very jobless during those times. There was a pandemic out there, so he had a lot of time, just like you guys have today. And what he did was he took many different objects and then he made them collide with each other and saw what was the relative speed of approach and what was the relative speed after the collision. So relative speed before collision and relative speed after the collision, that's what he saw. And he found that there was a ratio which was constant for a given pair of bodies. Means if you take wood and then you collide, he saw that the ratio of speeds was constant. If you take wood and marble, then it was different. If you take marble and marble, it was different. If you take marble and steel, it was different. So that ratio was an experimentally determined factor, just like coefficient of friction. So it has to be experimentally determined. And what is that value? So let me come to that. So imagine u1, u2, v1, v2 are initial and final speeds. Coefficient of restitution is E, which is relative speed. Again, relative speed. But what is there on the top? What is there below? Here is the answer. Always after the collision, some energy is lost. So after the separation, the speed is slightly less. Now this ratio is always less than 1. Remember that. So what should come in the numerator? Think about it. Separation or after the collision. So separation. And this word separation will be always for after the collision. And relative speed of approach, how they come close to each other. And that is nothing but your before the collision. Now let me give you some examples so that you get some idea. Say for example, I tell you u1 is 2, u2 is 3, and after the collision v1 is 1 and v2 is maybe this way, and let's say that is 2. Example. This is just an example, guys. Now what do we do? If I want to find the value of E in this situation, think about it. I have to create a ratio. What is there on the top? Speed after, that is separation. What is the relative speed of separation? That means sit on one and look at the other. That will give you relative speed. Sit on M1, look at the other guy. You have already seen what relative motion is all about. So obviously when they are going away, the speeds will add and that will become 1 plus 2. I hope that makes sense. And here what happens is before, that is there in the denominator, if you sit on M1 and look at M2, it will come closer towards you. With what speed? 3 plus 2. Think about it. Again adds. So 3 by 5 is the value. Is that clear? So that's the coefficient of restitution in this problem. Lot of textbooks and lot of people I know, they tell, oh no, you should not do it like this. Remember the formula, v2 minus v1 upon u1 minus u2, or v2 minus v1 upon u2 minus u1 with a negative sign, where all the things are in the same direction. Do not do that. It is very confusing. I have taught you relative motion. You know how to add or subtract speeds. That's it. If they are in the opposite direction, they add. If they are in the same direction, they subtract. And keep in mind, they are speeds. So always make sure numerator and denominator are always positive numbers. If you know that, that's it. You have got it. Amazing, Manoj. Yes, I'm rapping. Wow, I didn't know that. All right. No, coefficient of restitution can never be negative. I understand that. Ankit, I think you got it wrong. All right. So it's not negative. All right. So that's why a lot of textbooks put that minus sign and then you get confused. So understand what I'm telling you is a better way. Whatever is there or taught otherwise will be unnecessarily confusing. Excellent. All right. Let me give you one more example and then let's go into the problems, guys. All right. Let's see one more question. Let's say I make the values like this. This is 2. This is 7. And after the collision, this is let's say it's going like this, and let's say it's going with a speed of let's say 4, and let's say this is going with a speed of 5. All right, can you guys quickly tell me in the chat box what is the coefficient of restitution in this case? Come on, quickly. Come on. Very good, Suhas. Very good, Aishwarya. Thank you, Manoj. All right, Jumna, 9. 9 कैसे होगा यार? It has to be less than 1. What are you guys doing? Come on, think again. This is after, this is before. Be careful, be careful, be careful. Yes, NA, I'll do something like that. I'll plan something. All right. So after the collision, after is there in the numerator because that is always less. Both are going the same direction. So what is the relative speed I am going with 5, my friend is going with speed of 5. My relative speed with respect to him, think about it, will be subtraction. So it will be 5 minus 4. And approach before 7 and 2. I am 7 from somebody else is coming towards me with 2. So I'll see 7 plus 2. So that will be like this, and that will make it 1 by 9. That's the answer. I don't know why people are saying 1 by, oh sorry, that arrow mark was there. I am so sorry. Yes, that arrow mark was there. My bad. This was 7 and that was 2. So if I'm going the same direction and that is 2, then the relative speed will be, guys, 5. Yes. So that will be 1 by 5. My bad. That light is reflecting. I couldn't see that arrow mark. My bad. Yes. Yes. So sorry. Oh yes, Asmi, we will plan something. We'll plan some gifts and some, special fan club related goodies for all of you. We are planning something. Let me tell you that. Yes. Yes. Okay. I hope this is clear. Everyone understood how to do this. Always keep numerator and denominator positive, guys. Is that clear? Everyone, shall we go to some problems? Okay. So let's go to some problems. And before that, let me give you a very clear chart of elastic, inelastic and perfectly inelastic collision. So first important thing, yes, Asmi, many happy returns of the day. Elastic collision, congratulations Asmi, बहुत ही बढ़िया यार, तुम आज आए हो on your birthday. So elastic collisions, no kinetic energy is lost. All right, in inelastic collision, energy is lost in the form of heat, sound, deformation, etc., etc. In perfectly also, energy lost is in fact maximum. Maximum energy is lost, and it is lost again in the form of heat, sound, deformation, etc., etc. Next, for elastic collisions, coefficient of restitution is 1. This is one of the most important thing. The speeds of approach and the speeds of separation, both are equal. The ratio is 1. In inelastic collision is less than 1, and in perfectly inelastic collision E is 0. Remember that. I hope this is clear. All right. Milega Asmi, doesn't matter. As long as you are part of this family, if you are a part of this family, you are subscribed to this channel, you have been a regular student, and if we plan some goodies, as long as you are attending here, don't worry, we will plan something for you. Don't worry. Yes. Now, the most important graph which nobody gives you. Nobody gives you, guys. That's what I'm going to give you. You know what is that? Here it is. Many of the books and many of places, they do not give this. This is energy versus time graph. Yes, energy versus the time graph, and let's have a look at it. Yes, a lot of people do not know how it looks like, and here it is. When you talk about elastic collision, you know how the energy graph looks like? Why with respect to time? Because they will be colliding. All right, so if you play the time button, they'll come close, hit, deform, and then again go back. So how does kinetic energy change at different instants of time during the collision? And here it is. First, before the collision, it will be straight because nothing has happened. When the collision begins, the kinetic energy will go down, and again it will bounce back to the original value. So this is the duration of collision. So this is when they collide. So it goes down because for a brief moment there is some deformation, but after that again the deformation goes away. So the kinetic energy bounces back to the same value. Very important. This was in fact asked in different ways. In inelastic collision, which is the most commonly occurring collision, the graph is straight before the collision, obviously. Then the graph goes down, the kinetic energy goes down, but it does not bounce back to the same value. So again, this is the duration for which again it collides, and you will see there is some loss in the kinetic energy. So the kinetic energy gets lost in the form of heat, sound, etc. Is that clear, everyone? Amazing, amazing, amazing. All right, Suhas, thank you. And you know what the last graph is? It goes down, it's straight and it goes down like this and it remains flat. So this is max loss, maximum loss in the energy, guys. And this is again that collision duration. So they are colliding during this part. That's it. The energy is not even going to bounce back a little. It's just stuck and they move together. That's your perfectly inelastic collision. Is that clear now? No, it might not touch the x-axis. It may or it may not. Depends. If there are two bodies coming with the same speed of same mass, then after the collision they will stop. In that situation it will touch the x-axis or else it will not. Yeah, it will go very down, but depends how much energy. Because remember, see, lot of very good question, Kirito. Actually, a lot of people think in perfectly inelastic collision, once they stick, they do not move together. No, they can move together. Remember, always momentum is conserved, so they will have some energy left in some cases. Yes, ask me. Vedantu is also on TV, Airtel TV. It's going to come on Airtel TV. Why? Very well. Yes, yes, yes. What do you mean by optional questions, Ankit? I'm not sure what you mean. Can you please elaborate? So I hope you have made a note of it. And in case you have not made a note of it, you can always replay. Remember, even during the live sessions, you can slightly move the cursor. Have you tried it? You can move the cursor behind in case you have missed something and you can come back. And remember, guys, even if sometimes you are late by say 3 minutes or 4 minutes, you can quickly go back and you can slowly catch up with me even in the live session. Yes, you can do that. Yes, very good. Yes. Okay, so let's get going. Let's see how many of you can do this problem. Now a 4 kg ball moving at 48. Okay, don't worry, I'll do this for you. Okay, so pay attention, guys. I want you to solve it along with me. Just keep your pen and paper handy. This ball moving at this speed undergoes inelastic head-on collision with another ball moving in the opposite direction with this speed. What is the final speed? Okay, coefficient of restitution is given. So my objective is you should learn how to solve this. So pay attention. So this is my 4 kg ball and this is your 8 kg ball. 4 kg ball is moving with a speed of 48 meters per second and the 8 kg ball is moving in the opposite direction with a speed of 96, I believe, meters per second. This is, remember what I have told you, always draw 2 diagrams or else you'll make some mistake. And here it is. This is the 4 kg ball. This is the 8 kg ball. Now what happens after the collision? Who knows? Maybe only God knows. Alright. So what should you do? Assume. If you're wrong, automatically your answer will be negative. Don't worry about it. Don't break your head. So assume V1 is here. Assume V2 is there. What's the harm, yeah? Just do it, no? Just follow the conventions. That's it. Now, here is the first equation that you will write. What is the first equation you will write, guys? Momentum equation. Okay, what is the momentum equation? Initial momentum. Let's write it down. Initial momentum is equal to final momentum. What is the initial momentum? Mass into velocity, positive, because it's moving towards the right side. So I'm taking right side as positive. Oh, 8 kg will have negative momentum. It's coming this side, right? So keep that in mind. So minus 8 into 96 is equal to, this guy's momentum is negative because V1 is this side. So think about it. What will you get? You will have minus 4 V1 and this guy's momentum right side, so positive, so plus 8 V2. Now you can simplify this a little bit, like you can take away 4 from all the sides, so you will get 48 minus 2 into 96 is 192 is equal to minus V1 plus, plus 2 V2, I believe. Now just rearrange it a little bit and what will you get? 2 V2 minus V1. 48 minus 192 think about it, it will be what, 144 with the negative sign. Just check this out. Yeah, is that clear, guys? Everyone till this point? This is my first equation. Now there is a problem. The problem is I have two variables and only one equation. Please get me one more equation. Where do I get that equation from? What did I tell you? Yes, this is that information which is hidden, and that will give you your second equation. That's the hidden information. All right, coefficient of restitution is 2 by 3. And what is 2 by 3? Separation, that is after. I'll write it over here, and here it is before. After by before. After, what is the relative speed afterwards? Here both are going the opposite direction. What will happen to the speed? Add or subtract? Opposite. Obviously separation will add, right? So it will be V1 plus V2. I hope this makes sense. And this is approaching. What is the relative speed? 48 plus 96. So 48 plus 96. Okay, so let's rearrange and see what do we get. So 48 plus 96. How much is it? 144. So it will become 2 by 3 into 144 is equal to V1 plus V2. You play around with it a little bit. So 2 into 144 and divided by 3. Come on, guys. 2 into 144 divided by 3. Come on, I'm reading all your chats. Come on. How much is it? Everyone, come on. 48. No, I think it is 96. Yes, correct. So this will become V1 plus V2 is equal to 96, and that's your equation 2. Now you have two equations, two unknowns, solve it. You'll get the answer. Come on, guys. All the dear V enthusiasts, come on, you can do this. Let me know what the answer is. How much is the value of V1 that you get and how much is the value of V2 that you get? Come on, use your brains, whack your brains, find out the answer. What is the value of V1? What is the value of V2? Yes, come on, guys, fast, let's respond. Come on, even the channel manager is telling this. Come on. 17S Harni, we do not know that, we have assumed it. If I'm wrong, then automatically the answer will come out to be negative. Is it both positive? Think again. I don't think both are positive. Just check. Just check again. Yes, correct, Saurabh and Saiji. Yes. So V2 comes out as minus 16 and V1 comes out. Check it out. Is it coming out as 112 meters per second? Very good. You guys are very fast. Yeah, congratulations. Now, what does this data tell me? What does it tell me? V1's direction is correct, but V2's direction is wrong. Where did I assume V2? There. That is wrong. It should actually be here, but there is no harm. In options, you will be given left side, right side, etc. So magnitude wise it is correct, 16 only, just direction wise it is here. I hope now you understood how to solve coefficient of restitution problems. Is that clear? Let me know in the chat box. Come on, everyone. Is it clear now? Have you got that confidence now? Have you understood how to use this equation? Did you understand? Asmi, don't worry, I know you are in 10th standard, you will get that speed slowly, and you are competing, Asmi, with 11th and 12th and dropper students, so that's one thing you should be proud of. Don't worry. Very good. Super class. Amazing. Let's go to the next question. Yes, 16 and 112. That's the answer. Let's see how many of you get this now. A neutron collides with helium nucleus, which is at rest, with speed u. If the collision is elastic, yes, you might be wondering, sir, where do you think elastic collisions happen? I have not seen elastic collision perfectly happening. Well, they happen at molecular level, interatomic level. That's where the collisions are elastic, perfectly elastic, E is perfectly equal to 1, not even 0.99. It is exactly equal to 1. That can happen at molecular level. So that's why I took this example, because a lot of you have that question. All right, very good. So now, how 48 plus 96, Barney, if two things are going in the opposite direction, they will add, right? Relative speed. That's how. Okay, so let's assume these things. First, start. This is a neutron. Assume the mass of neutron. How much? M. So if mass of neutron is M, what should be the mass of helium? 2m, 3m, 4m, 5m. How much should it be? Think. How much will it be? How much should it be? M, 2m, 3m, 4m. How much should it be? Very good, VSG. Correct. It should be 4m. And this speed is u. This is at rest. After the collision, what will happen? Well, after the collision, this neutron has a speed v1 and this helium has a speed v2. Now just assume, if I'm wrong, you know what will happen. Automatically something will come out to be negative. So don't worry about it. Chalo, let's start doing the problem. So first equation, we all know what should we do. Momentum is conserved. So initial momentum is final momentum. Let's do this. What is the initial momentum? M into u plus 0. Why the 0? This dude was at rest, so give him 0 momentum. Afterwards, what is the mass velocity? Okay, so it is m into v1. Great. Positive, because right side is positive, do not forget. And 4m into v2. So plus 4m into v2. Okay, cancel out m, guys. That's better. And you will get u is equal to v1 plus 4. Plus 4 v2. That's equation 1. But we are not done yet. We need one more thing, and that is restitution. So restitution equation, E is 1. That's the value of E, guys. And that's after by before. Look at that. Both the velocities are in the same direction. So what should happen? The relative velocities afterwards should subtract. But should I write v1 minus v2? Or should I write v2 minus v1? That's a common question which people ask. What should you write? v1 minus v2 or v2 minus v1 on the top? What should we write? Okay, Aishwarya says v2 minus v1. Yes, mass is your favorite variable because often it gets cancelled. Very good one. Yes, it should be v2 minus v1. Why? Because after the collision, that dude is going to move faster than the neutron, right? How can neutron move faster than the helium? Because if neutron moves faster, then it will collide again. Once the collision happened, that's it. Again the collision won't happen, right? That's it. The collision is done and dusted. So v1 has to be less than v2. Remember that. Remember that. Okay, right? So hence the bigger one minus the smaller one. And then before the collision, the relative speed was u. Therefore, u is equal to v2 minus v1. That's my equation number 2. Now you know what to do. Add both of them. Alright. So just add both of them and see what will happen. So 1 and 2, I'm just adding them. And what will I get? Think about it. U plus u, 2u is equal to v1 and v1 got cancelled. 4v2 and v2 will give you 5v2. Therefore, v2 is 2 by 5 times of u. Got it. v2 we got. Similarly, you can find v1 from this. So v1 you can use this equation. So using equation number 2, u will be equal to 2 by 5 u minus v1. So therefore, v1 will be equal to 2 by 5 minus 1. Think about it. 2 by 5 minus 1 into u. Therefore, v1 will be equal to minus 3u by 5. This is one answer. And this is my second answer. What does this negative sign tell you? What does this tell you? Yes, the neutron's direction was assumed wrong. No problem. It's okay. Magnitude is correct. This minus sign tells me it is moving here. That's it. If somebody solved the problem assuming this side, then he would have got the answer as plus. But you would never know that before solving the problem. So it's fair enough to assume it. I hope that's fine, guys. Let me know. Are you now going to get a lot of confidence to solve these problems? This is how it can be applied even in atomic structure, nuclear physics, collisions related problems. Yes, the modern physics problems also can be solved using momentum and conservation. Very good, excelente, perfecto. Very good guys, very good, easy peasy, lemon squeezy. Let's going to the most amazing problem. You drop a ball from some height h0. If the coefficient of restitution is E, what is the height the ball reaches after n number of bounces? Every time the height reduces, what is the height it reaches after n number of bounces? Let's do this. Barani, mass of helium. What is there in helium nucleus? How many protons, how many neutrons? And if each neutron and proton roughly have the same mass, now can you understand why it is taken as 4m? I hope that is clear. HO means H0. Sharan, H0. Sharan, which standard are you in? Alright, so let's do this problem. Okay, so let's get going. Well, Dhruv, I'm very good. Come on. Let's get going. So initially, what did I do? I dropped the ball from height h0. Then what happened? The ball only went till height h1. Then what happened? The ball only went till height h2. And after some more collisions, the ball only went till height hn. Okay. Now, here is what I'm going to do. I'm going to approach this problem very interesting way. See, when the ball first time hits the ground, it will hit the ground with velocity v0, correct? As soon as it collides, it will lose some energy and it will rebound with some lesser speed. Let's say v1. It will go up, stop, come down, and it will again come down with the same speed v1. Okay, so the speed will be again v1 only over here, both the times. I hope it is clear. This was h1. Now, both the times it was v1. Now when it hits with v1, understand, next time it will go up with even lesser speed. And let's say I call it v2. And when it comes back, obviously it has the same speed. And next time it will be v3, v4, v5, so on and so forth. And this speed for going up and coming down will be vn. Is this logic clear till this point? Is this logic clear? Well. As height varies, even speed varies. Yes, Manoj, but these are not the speeds at any random time. These are the speeds just before or just after the collision. So that's why I have taken the specific values. Alright, great. Now, here is the logic. Do you remember the formulas? When you drop something, what speed will it hit the ground? I have told you that. So, if you remember the formula, root 2gh. This is the velocity just when something hits the ground. That's it. Use it and you will start getting v0. So, v0 will be root 2gh0. Correct? Now, when you throw something up, the maximum height reached, what is the formula? Velocity square by 2g. You have studied this. So, for this collision, or when it hits first time and it goes up, what is the maximum height reached? h1. h1 will be velocity square by 2g. I hope this is clear, but this is v1. Keep that in mind. Now, let's use the knowledge of restitution. What does the knowledge of restitution tell me? It says, if the coefficient of restitution is E, I need the relative velocity after upon relative velocity before. What is the collision happening between the ball and the ground? The ground never moves, so it makes our job even more easy. What is the speed after? Well, that's v1. And what is the speed before, just before? It is v0. So therefore, v1 is nothing but E times of v0. Look at that. Just use it. Just use it and you're going to get everything over here. So let's try this out. Use this over here. Therefore, h1 will be E square v0 square by 2g. Oh, but wait a minute. I know the value of v0. V naught square will be 2g h naught. So it will become E square 2g h naught by 2g. Best part, 2g goes. Therefore, I'll get h1 is equal to E square h naught. So I got h1 as E square times h naught. Now this is the most interesting thing. Ali, please don't spam, else you will be banned. Remember that by the channel manager. Now here comes the next part. Think about it, guys. Think about it. When it reaches here, isn't this height the initial height for the next collision? So won't this height be E square times this height? Just like this height was E square times the previous height. This is like dropping the ball from here and it hits back. So this height will also be E square times h1. So hence, can I not say h2 will be E square times h1? Is that logic clear? Very good, very good, very good, very good. So hence, just substitute the value of h1. What will you get? h2 will be equal to E square times E square h naught, which will make it E raised to 4 h naught. That's h2. Now observe the trend. Which trend? This is h1. This is h2. Think what will be h3, sorry. What will be h3? E raised to what? E raised to 6, E raised to 5, what will it be? Every time the power increases by 2. So it will be E raised to 6 h naught. That's what you will get. So that's the next number on your screen. That's h3. So now, did you get it? What should be hn? Did you get it? What should be hn? Think about it. hn will be E raised to something h naught. But what is that something? It is always 2, 4, 6, 8. What are these numbers? Even numbers. And how do you best represent even numbers? 2n. And that's it. That is the answer. E raised to 2n. N is the collision number. Not n, Rishikeshwaran, it will be 2n. Alright, alright. I would request the channel manager to please stop Karan from spamming, else he will be banned. Very good, Ankit. Alright, very good. Karan, last warning before you get banned out here. Okay, very good. Uncharted, which part did you not understand? Please tell me. See, I'll tell you what we did. This part will be very clear. Initial velocity was root 2gh. Maximum height is u square by 2g. And coefficient of restitution says speed of separation upon speed of approach. Now V1 is EV0. So just substitute it over here. You will get E square V0 square. V0 you take it from there. That root symbol goes. You will get it as 2g h0. And solving you will get h1 is E square h0. Okay. Now what did we do? Think about it. This height is E square h0. This height is E square times this height. So won't the next height be E square times this height? That's what I did. So this height h2 will be E square times h1, but h1 is E square h0. Just put it there. You'll get h2 is E raised to 4 times the original height. Now by the trend, obviously h3 will be E raised to 6 times the original height. So notice the trend and you will see it's all even numbers. I hope this is clear. Very good, Siddharth. Very good. Very good. You guys are like the firewall. You guys are much better than the Windows Defender out there. Very good. Very good. I'm proud of you guys. You guys must be very proud. We enthusiasts. Very good, guys. Understood. Very good, Uncharted. Very good, Manoj. Very good, Aarti, NVD. Very good, Aryan. Very good, Sneha. If it is odd, then Sneha, it will be 2n plus 1 or 2n minus 1 depending on how you want to start n. Okay, so 2n plus 1 is always an odd number. Now let's look at some 2D collisions. Bernie, the next chapter for 12th, first we'll complete electricity and then we'll start. Electricity, only one chapter is remaining. That's dipoles and dielectric. After that, I'll be starting current electricity. Alright, so let's get going to 2D collisions. Let's observe. Oh, my bad. Oops, I think he was going for a birthday party. Look at that, 2D collisions. Alright, so this is one of the most famous problems and you are going to remember whatever result I'm going to give you, because you know why? It is going to save you a lot of time in the JEE Mains, JEE Advanced, KVPY and all such competitive examinations. So remember whatever result I'm going to give you now. So observe. Yes, Arti, please don't cry. Alright. Okay, so now here is the thing. Yes, somebody said optics. Who was that? Somebody said optics. Bernie or somebody else said optics. Very good. You are going to see some similar result. Now this ball hits the ground surface or some surface and the angle of reflection, and this is the angle of incidence. Inke beech mein rishta. What is the rishta? What is the relationship between I and R? That's what I want to find. Here is the logic. See, when it hits the surface, there will be a sudden force like this, impulsive. If the impulsive force is along the y-axis, there is no force along the x-axis. That's it. Since the net force in the x-axis is 0, therefore the momentum initially in the x-axis and the momentum finally in the x-axis must be conserved only along x, not along y. In fact, along y it is reversed. I hope that makes sense. Oh, so now what is the initial momentum in the x-axis? Well, that's very easy. It's not that difficult. This is initial velocity u. There will be a component here and a component here. And when it rebounds, it will rebound with velocity v, and there will be a component here and a component here. It's not that difficult to see that if this angle is I, obviously this angle is going to be I, and if this angle is R, then this angle is also going to be R, of course. Now just plain simple resolution. So what is the initial momentum in the x direction? It will be mu and what is it, sine I. So mu sine of I, correct? What is the final momentum after the collision in the x direction? mv sine r. So mv sine r, and bichara mass again just like usual, cut gaya, gone. So you will get u sine I is equal to v sine r. That's my first equation. Is that clear? Just momentum conservation in the x-axis. All right. Now, no, both velocities are not equal. Who said the collision is elastic? That's why guys, you do not win in carom or pool. That's why you should study physics under me. Because a lot of people say, sir, final velocity will be initial velocity, angle of reflection is angle of incidence. Bhai, if that was true, then why will you be studying over here? That's not so easy. Observe. Okay, now here comes the next part, restitution. Now there is one thing which I did not tell you in restitution. I kept it a secret. You know what is that secret? I'll tell you now. This was after and this was before, right? Do you know what I did not tell you? I was waiting for this problem. So that's why some people who fast forward in 2x and all that gone, they will miss out on all these important tricks and pointers, and that's why they will make silly mistake. So very important, never to fast forward a video unless and until you know that I'm discussing something else. Alright, so here is the trick. The trick is you should only apply this equation along the direction of collision. Collision or impulse. Only these velocities should be measured along the direction of the collision. Now what is the direction of collision or impulse? It's very obvious here. There is a sudden impulse this way So all the velocities only in the y-axis should be accounted for, nothing else. So that is the catch, and if you know this, only then you can solve the problem. So let's do this. What is the value of E? I do not know, but it is just E. So E will be, after the collision, what is the speed? V cos R. That's the relative speed from the surface, only in the direction of impulse. So V cos R. What is the speed before in the direction of impulse? U cos I. That's the cos component. So U cos I. Rearrange, take this over there. You will get U cos I and E is equal to V cos R. What are you going to do? Divide. Yes, please divide both of them and you will get the answer. So divide. 1 divided by 2 will give me, think about it, U sin I by U cos I. U will get cancelled. So I'll get sin I by E cos I is equal to VV goes cos R, VV goes sin R by cos R. So sin R by cos R. Sin by cos, tan I. Sin by cos, tan. So tan R is equal to, take that E upstairs, is equal to E, and that's it. This is your answer. Remember it. Does it look like Snell's law? Yeah, it looks like Snell's law, right? In Snell's law, what was it? Sin I by sin R is coefficient, what? That refraction. That was the refractive index. Here it is tan I by tan R is E. And remember one thing, if the collision is elastic, that means E will be 1. Tan I will be equal to tan R. That means I will be equal to R. So angle of incidence is angle of reflection only in elastic collision. In fact, if the collision is inelastic, then the E value will be point something, 0.3, 0.4, 0.7, anything less than 1. So if it is less than 1, numerator will be smaller, denominator will be larger. So I will be smaller, R will be more. So if it comes and hits at 30 degrees, it will rebound at more than 30 degrees. I'm pretty sure you're shocked by this fact. How was this? No, they are not related, Bernie. It's just a coincidence. Yes. I hope this is clear. Yes, example of elastic collision will be light bounding from a mirror. Yes. In case of perfectly inelastic, it is 0. That's it. It will just get stuck or whatever. Okay, so use this in carom and pool or any kind of collision related sport or any event next time, and you will remember me. And if you loved this fact, do not forget to hit that like button out there. Come on guys, you have to hit the like button if you loved this problem. Next question coming up on your screen. Okay, let's see how many of you get this. And if you are new, please hit the subscribe button. Come on, if you are new, you should hit the subscribe button. After perfectly inelastic collision between two identical particles moving with the same speed in different directions, the speed of the particles become half the initial speed. The angle between their velocities of the two bodies before the collision is. Chalo, come on. I'll give you 1 minute and 30 seconds. Let's see how many of you get this. Okay, come on. Guys, you have to give thumbs up, not just in the chat box, in the video below. You have to hit that like button there. Yes. Very good, Princey. Very good. Aryan, come on, get going with the problem. All right, let's see, come on, we have almost 50 seconds. You can still do it. Very good, Aryan, very good. Let's see, Ankit. Don't worry, ask me, we'll discuss the solution. All right, keep your answers blocked, just type it out so that I know what you guys have answered, and I'll be seeing all your answers and see the proper solution also. Very good. Jackwell, Deepa, come on, come on. Lot of new members. Princey, Bula, Deepa, Jackwell, Bernie, Fida, come on, come on. Let's see. Krito, Saurabh, Asmi, Ryan, come on. Owen, all right. The time is up. You know that. And the correct answer is C. A lot of you got it correct. Sneha, Owen, Manoj, Ryan. I'm just going to scroll up and see. Yeah, I think even Princey, Jackwell, even Baula, and I think even Ashmi, he thought about something, and then even Amit Kumar. Yes, very good guys, very good. Acha. So Aryan, why have you kept your name as Aryan? Why not Gaurav? So here is the logic. See guys, these two masses are equal. Alright? And let's say the angle between them is 2 theta. So just let's figure out how much is theta. They both come and they undergo a perfectly inelastic. That means they stick together. And once they stick together, they will move along the x-axis. So initial velocity was something u. Both come with the same speed, I believe. That's what is given. And their final speed becomes half that word is given. So that means this speed will be u by 2. What should we do? Use conservation of momentum. But in which direction? X direction. That's the most easiest one. So use the conservation of momentum. Initial is equal to final, but in the x direction, remember. So what is the momentum in the x direction? mu's which component? Cos theta, because even this angle will be theta, right? Do not forget that. This angle will be theta. So if this is mu, this will be mu sine, that will be mu cos. So mu cos theta plus, do not forget this mass. Alright, so mu cos theta is equal to total mass 2m. Alright, so it is 2m. And what is the speed? Just u by 2. Oh, as usual, m goes off. No izzat only. And this will become 2u cos theta. 2 goes, it will become u. In fact, even u goes off. And cos theta will be half. So theta will be 60 degrees. The question was angle between the velocities. That means the total angle. So the total angle will be 120 degrees. Is that now clear? All right. Yes. Thank you, Princey. Very good. Thank you, Princey. Thank you. Very good. Chalo, let's get going to the next question coming up on your screen. Now, before I give you the next question, did I not tell you that I'm going to give you special tricks? Yes, special tricks, my own tricks to solve some problems in shortcut ways, only in some special cases. So these are some special cases which you should remember. Just like that formula I gave you. Tan of I by tan of R for a 2D collision is E. Remember that, Snell's law like. Alright, so let's get going. Very good, Ankit, kya baat hai? So, first pointer, remember. Oh, by the way, let me tell you. Sorry, this word was not supposed to be inelastic. Guys, I'll cancel this. This was supposed to be only in case of elastic collision. So this word in is not there. Please, when you're making notes, please write it down only for elastic collisions, not for inelastic or other. E is equal to 0. Only when E is equal to 1. This is the most important pointer. Only when this is 1, then you can apply these tricks. So let's see that. First thing, exchange of velocities. Very important. I think you have seen this GIF before as well. If a mass collides with other mass which is equal, then their velocities get exchanged. So, exchange of velocities. So I can say, when you have two masses, this is before, and this has velocity u, this has velocity v. Now, after the collision, this is after, you will see if the collision is elastic in nature, that is E is equal to 1, then you will see this mass will get U and this mass will get V. So their velocities get interchanged. That is the most important property. Remember that. Only when E is 1, not otherwise. Remember. Alright, very good. So first property, I hope you have written it down. Exchange of velocities for elastic head-on collisions. The velocities get interchanged. This diagram explains it all, self-explanatory. Very good, very good. Let's get going to the next question. Sorry, next property, my bad. So small mass colliding with heavy mass. Imagine, have you seen the movie Kung Fu Panda? Panda is standing there, something comes, hits his body, and then nicely in slow motion it gets rebounded. Have you seen that? Have you seen that scene, guys? So that's this property. So if you have a big mass, or if you have a friend who is very fat, and you are very tiny, then if you go really fast running towards him, and then you hit him, and then you will get rebounded with the same speed, assuming there is no loss of energy, and your fat friend will be just standing there. So that's what is happening over here. So when a very small mass, m is much smaller than this bada M, and it comes and hits with some speed, and let's say this was at rest, then after the collision, okay, just one sec. Now this is after the collision. This was before the collision. So after the collision, what happens is, you will see the smaller mass goes back with the same speed and the bigger mass is still at rest. But how big the difference should be? Very big. Like for example, small m is 1 kg, then capital M has to be at least some 1000 kg or something. Understand? Only then. If one is 1 kg, second is 3 kg, then do not apply this trick. You will get a wrong answer. Remember that. Alright. Yes. So basically, the mass difference should be very large, or else this trick should not be applied. And do not forget, E should be 1. E is 1. These are only for elastic collisions. Remember that. So this is the next trick which you can use. There is a question coming up. I hope you have written this property down. Alright. Motu and Patlu, yes. Earth and the sun, yes, will work. Earth and the sun, the mass difference is very huge. Alright, next. Imagine your Motu friend comes running towards you. You have made him angry and you are standing there like this, and he comes and hits you. What will happen to you? You will just fly off. But with what will happen? Let's see. Okay, so this is the situation before. Let me draw the situation after, and obviously E is 1, and this is afterwards. Okay, I should draw it probably here. Okay, and now what happens is, imagine if your Motu friend is coming with speed u, and you are Shanti say standing over there, Bichara at rest. Then after the collision, the Motu friend is still going to go with the same speed. His speed will not change, but your speed will be 2u. Twice the speed. Remember that. Very important property. Alright, tree and a bird, Dolu, Bolu and Kalia. Okay, I don't know who these friends are. Yes, yes, Clary, yes, Jackwell, yes, Manoj, Princey, Ryan, Fida. Correct. Alright, is that clear, guys? Remember it. Last property. You would have done this, or you would have seen this kind of shots in carom, in pool, and maybe some other sport. Hitting the ball at an angle, tuck, it goes, cuts it. Have you seen this? Have you played this shot sometime? Wow, yes, a lot of you have done that. Yes, billiards and all. So, next property. If a ball comes and hits a similar ball, very important, similar ball, but at an angle, then after the collision they both move like that. But you know how they move? That's the most interesting part. They move perpendicular to each other. How do they move? Perpendicular to each other. Very important property, and I will prove this to you. And you'll be fascinated. You are going to love me after this. How? You will see. This mass is M, and this is M, but this is at rest. And after the collision, this is V1, and let's say this is V2. Okay, this is how it looks like. What do I want to prove? V1 and V2 are perpendicular to each other. Is everyone clear? All right, let's see. How do we do this? Momentum conservation. So, initial momentum should be equal to final momentum, but in vector form. I'm going to use vector form. So what is the initial momentum? mu bar. The other guy's momentum 0. This guy's momentum after m v1 bar. No component, I put the bar, right? This guy's momentum m v2. M bechara again got cut, yaar. I mean, so sad. Are you not feeling pathetic for him? I mean, so many times. I mean, izzat hi nahi hai. All right, so many times. V1 plus V2. That's my equation 1. Now, what did I tell you? In case of elastic collisions, E is equal to 1. E is equal to 1. Okay, thank you, Sneha, thank you. All right, so guys, in E is equal to 1, energy before and after is same, remember that? So let's use that. Kinetic energy initially is kinetic energy afterwards. What is the initial kinetic energy? Bolo zara. Initial kinetic energy is half m u square. Other guy, bichara at rest, is equal to what is the final kinetic energy? Direction does not matter. Kinetic energy is a scalar quantity. Do not forget that. So half m v1 square plus half m v2 square, guys. You are going to see one amazing thing. Wait for it. Half m. Arey, m bhi gaya, 2 bhi gaya. All right, both. M as usual. I feel very bad here. Very sad for him. Okay, so u square is equal to v1 square plus v2 square, guys. This is my equation 2. Look at both these equations. See, what do you feel? U vector is the resultant of V1 vector and V2 vector. The resultant is U vector. Don't you see that? U vector is the resultant of V1 vector and V2 vector. But what does this next line tell you? U vector square is V1 square plus V2 square. That means what? Pythagoras, guys. Yes, Pythagoras. So what is Pythagoras by perpendicular? So this is U, this is V1, this is V2. Did I not prove V1 is perpendicular to V2? Did I prove that? Yes or no? Yes or no? Done. Job is done. The proof is done. Done. Is it clear, guys? What an epic problem. What an epic solution. If you love this solution, hit the like button again. Oh, don't dislike it, but okay, what an amazing solution this was. All right. Very good. Chalo, let's get going. Let's see how many of you get this problem, guys. Come on. 1 minute. All right, excellent. Epic. Very good. Yes, easy peasy lemon squeezy. Come on. Find the final speeds, both VSG, not just one. Both. Small and the big one. Come on. Both are moving in the same directions, by the way. What happened, Gaurav Mishra? Arey, very good, Nishant Pandey. You are back. So why are you putting that stop symbol? All right, all righty, and the time is up. Okay, so let's see. See guys, okay, one sec. There we go. And what is given? Small ball moving with 5, huge ball with 7. All right. So both are moving the same direction, I said, right? Both are moving the same direction. So that means, if assuming they are in the same direction, so the bigger speed should be 7 like this, and the smaller speed should be like this. Just check this out. Because if 5 was here, 7 was there, think about it, they will never collide, no? I am moving with 5, the bigger mass is moving with 7. What, you are going to keep running behind him? It will never collide. So understand, the direction should be like this, assuming that their directions are same. Okay, so probably I didn't mention it exclusively here. So let me mention same direction they are moving. Okay, now what happens afterwards? Let's think. Now here is the logic, guys. Observe this. What I'm going to do? I'm going to change my frame. Yes, I'm going to change my frame. You know what I'm going to do? I'm going to sit on the big ball. Okay, I'm going to sit on the big ball. So what will I see the small ball bichara doing? I will see it coming towards me with a speed of 2 meters per second. Agree or disagree? Agreed, everyone? If I am on the big ball, look at the small ball, it will appear to come close towards me with a speed of 2. Correct? And what did I say? No, Krito, I mean bigger ball is easier, but you can do it otherwise also. So what did I say? A small ball hits a big ball. What will happen? The small ball will come back with the same speed. Remember that? So what will happen after the collision? Think about it. After the collision, if you are still sitting on that same frame, you will see this ball moving with the same speed with respect to that bigger ball. Yes, with respect to that bigger ball. But do not forget, the bigger ball will continue to move with the same speed. It will continue to move with the same speed. Now think about it, guys. You are sitting on that big ball, and what speed are you moving? 7. For me, that guy is moving with the extra speed of 2. That small ball, for me, is moving with the extra speed of 2. My own speed is 7. So actual speed with respect to you, how much will it be? How much will it be? Come on, think about it. It will be 7 plus 2, which is 9. That's the catch. Is it clear, guys? Oh, green color is not visible. My bad. Let me do something about it. So whatever I wrote in green, I'm rewriting it again so that everybody can see. Is it now clear, everyone? Is it now clear? Very good, Aryan. But actually this is for class 11th and 12th. You have come little bit early, but it's okay as long as you understand it. But it might get complicated at times because you are in 10th. Yo, wow, Jackwell, you are American, but I hope you know a little bit of Hindi. Don't worry, it's not a Hindi channel, but still, sometimes I might crack some Bollywood music and song related stuff, all right? Okay. So, there we go. What a problem it was. Okay. So, this is a homework problem. Let's see how many of you get this. Post the answers. Where will you post the answers? In the comment section below. After the class, not now. So after the class, you're going to post it. I will post the solutions in the Telegram group, and all the dropper and the 12th standard students crash course is also there for you as an option, and it is at a much less price than the subscription course. Because in the crash course, you only get crash course. If you don't want those micro courses and other stuff, it's okay. You can only attend the crash course, and the crash course has tests and part syllabus tests, doubt solving from all our experts from 8 AM to 11 PM. And also we are going to cover the entire JEE Main syllabus as per the new pattern with 120 sessions. Remember that. And also you are going to get amazing tips and tricks related sessions, and it's a two-way platform on our regular Vedantu app or on our Vedantu website. And how do you enroll into it? You can go into the description box and you can hit the link. You can see the crash course details. The original price is 10,000. After discount of 20%, you will get it for 8,000. And how do you get the discount? A coupon code. Which coupon code? Different coupon code, SHCC. Pass it on to your friends if you think it will be useful for them. Do not forget to share the coupon code with your friends, your loved ones, your relatives, or else you can also use it, SHCC. And this is our Telegram group where I'll be posting all the solutions after some time, but not today. I want you guys to give it a try. Post all your answers in the comment section below. All right. And if you loved today's session, and most of you would have already loved it by now, but still like it. And if you're new to this session, do not forget to subscribe, because the way YouTube works is unless you like and subscribe, YouTube won't suggest you our videos and you might miss out on all our videos and amazing sessions that we conduct. So I hope you guys have enjoyed today's session. You guys have loved today's session. You guys have, and I hope you guys had an amazing time. Very good. Love to see all your comments. Love to see all your chats. Love to see all your goody smiles, your stars, your hearts, your fires, everything. Thank you guys. Bye bye. Take care. See you. Have fun. Stay safe. Stay at home. This was Shreyas here, your master teacher.